Hello guys, myself Virendra Kumar, professor and scientist. In this episode, I am going to talk on thermal effects of current. So welcome back to the Science World podcast YouTube channel. Friends, heating effects of current. If under the influence of an electric field, a charge Q flows through a resistance R in time t, when the potential difference across the resistance is capital V, the work done by the electric field on the charge will be given by V times I times T. This work appears as thermal energy in the resistor. This is because the electrons accelerating by the applied field continuously lose their excess energy by collisions with lattice. This in turn increases the thermal energy of the lattice vibration and hence temperature of the resistor increases. So the energy is dissipated and that is given by I square RT divided by 4.2 calorie. Joule was the first who recognized and verified it experimentally, and that's why it is called Joule heating. So regarding heating effect of current, it is important to note that heating is directly proportional to the square of the current in the resistor. That is, heating effect of current is common to both DC and AC type of current. This is why instruments and appliances such as filament bulb, heater, geyser, press, toaster, etc. work both on DC and AC. Joule heating effect is irreversible. That is, on reversing the direction of current in a resistor instead of heating, cooling doesn't result. That means there will always be a heating effect whether the current is reversed in direction or not. Due to Joule heating, power consumed by a resistor in watt will be given by voltage times current, that is potential difference into current is equal to V into I and is equal to voltage squared divided by resistance. So if resistances are connected in series, that is if current is same in all the resistances, power consumed is directly proportional to the resistances. That means in series potential difference and power consumed will be more in larger resistance. However, if resistances are connected in parallel, that is, if potential is same in all the resistances, then the power consumed will be inversely proportional to the combined effect of resistance with current inversely proportional to the combined resistance. That is, in parallel current and power consumed will be more in smaller resistance. This in turn implies that more power is consumed in larger resistance if resistances are in series and smaller resistance if the resistances are in parallel. Friends, do you know that an electric appliance consumes the specified power only if it runs at the specified voltage? If the applied voltage is greater than the specified voltage, the appliance will get damaged, as in this case, current will exceed its current capacity. And further, if an appliance is made to run at a lower voltage than specified, the true power consumption will be less. Hence, do you know that filament bulbs get fused when they are switched on? Yes, this is because with the rise in temperature, the resistance of the bulb increases and becomes constant in its steady state, so the power consumed by the bulb initially is more than in steady state, and hence the bulb glows more brightly in the beginning and may get fused. Also, due to the evaporation of metal from the filament, the filament of the bulb becomes thinner and thinner with use. This in turn increases the resistance of the bulb. And as P is equal to V square by R, the brightness of the light emitted by a bulb decreases gradually with its period of use. Now I will tell you the connection of bulbs in series and parallel. Then what happens if the bulbs are connected in parallel and a voltage V is applied across them, as usually is the case in our house wirings. In that case, voltage across each of the bulb will be same and the current flowing across each bulb will be inversely proportional to the resistances of the each bulb. So in parallel groupings of bulbs or electric appliances, power, current will all be inversely proportional to the resistances and the voltage across all the appliances or bulbs remains constant. That is in parallel grouping of bulbs, the bulb of greater wattage will give more bright light and will pass greater current through it but will have lesser resistance and same potential difference across it. Also, if one bulb gets fused, other will work, that is, other will give light. However, if bulbs are connected in series, then in that case, current will flow same in each bulbs or appliances and potential difference will be proportional to the resistances in each appliances. So in series grouping of bulbs, power, voltage and resistance all are inversely proportional to the wattage and current remains same in the series groupings. That is, in series groupings of bulbs, bulb of greater wattage will give less bright light and will have lesser resistance and potential difference across it but same current. Also, if one bulb gets fused, the other will not work, the other will not give light if the connections are in the series. Friends, do you know why we use fuse in the household wirings? It is a metallic conducting wire of 75% lead and 25% tin. It has low melting point and is put in series with an appliance. It is a safety device which protects the appliance from getting damaged by melting and opening the circuit. If the current in the circuit exceeds the current capacity of a fuse is independent of its length and varies with its radius. Higher is the radius of the fuse, higher is the current capacity of it. Friends, do you know why long distance power transmission is carried out at high voltages? Yes, the long distance power transmission is carried out at high voltages because when power is transmitted through a power line of resistance R, power loss is inversely proportional to the square of the voltages. That's why if power is transmitted at high voltage, the power loss will be small and vice versa. Friends, I hope you enjoyed this episode. So subscribe the channel Science World Podcast and give the thumbs up. Thank you.